Hello, in this discussion we talk about periodic properties to find exact values of trig functions. In layman's terms, what that basically means is we can evaluate trig functions at certain smaller angles that are exact, but when they can become larger, people have a little bit more trouble. So for example, if I was wanting to find the sine of 405 degrees, you might balk at that because a 405 degree angle is rather large. But if you remember, 405 degrees is coterminal with 45 degrees because you can back up 360 degrees on a unit circle. So 405 is coterminal to 45 degrees. And so to evaluate the sine of 405 degrees, since they have the same y-coordinate on the unit circle, they would be the same as taking the sine of 45 degrees. And we know the sine of 45 degrees is square root of 2 over 2. And so sine of 405 is also square root of 2 over 2. And in essence, that's what this discussion is about. All right, so let's look at this picture. So we have a point, this time it's pi over 3. And if we go all the way around and come back to it, that's pi over 3 plus 2 pi. So taking any trig function at pi over 3 would be the same thing as taking the trig function at that pi over 3 plus 2 pi, which is 7 pi over 3. All right, so it doesn't really matter. Now, if theta is in the second quadrant in the second diagram, if you want to go all the way around again, it's going to have the same y-coordinate. So you can keep adding 2 pi and keep subtracting 2 pi and evaluate the trig function at those locations, and it would have the same value as the trig function evaluated at theta when it's less than 360 degrees. So in other words, if you know trig function evaluated at a certain theta, then you know a lot of thetas that you could actually evaluate that same function at. So if you know the sine of 120 degrees, you'll know the sine of 480 degrees because 120 and 480 are coterminal because 480 is one revolution past 120 because you add 360 to it. And so therefore it's you have the same value. In essence, that's what we're doing. And here it is. This is the summary of that. So sine of theta plus 2 pi k is the same thing as the sine of theta. And then cosine of theta plus 2 pi k is the same thing as cosine of theta, where k is any integer. A function is called periodic if there is a positive number p such that whenever theta is in the domain of f, so is theta plus p, and alpha theta plus p is equals to alpha theta. So in that last example, the p was 2 pi because I can go all the way back around and come back to it. So alpha of theta plus 2 pi is equals to alpha of theta. In other words, sine of theta plus 2 pi equals the sine of theta. So that's what that last one was referring to. And if there is a smallest such number p, this smallest value is called the fundamental period of the function. So what that basically means is p could be a lot of different numbers, but the smallest one that it repeats is the fundamental one. So for example, I could say sine of theta plus 4 pi is equals to sine of theta, and it would be true because 4 pi is 2 revolutions around, but you end up back in the same place. Sine of theta plus 6 pi is equals to sine of theta as well. But that's not the smallest one that it does. 2 pi is the smallest. So 2 pi is 1 complete revolution. 4 pi is 2 complete revolutions. 6 pi is 3 complete revolutions. So 2 pi is the smallest one in this case. Now let's look at this one. Look at the tangent of theta. Now tangent of theta is, you remember, is the y-coordinate over the x-coordinate, so it's b over a. So b is positive and a is positive in the first quadrant. Now in the third quadrant, if you add 180 degrees or just pi, then it's going to be negative a over negative b. I mean, negative a comma negative b is the point over there. Okay, I think they call it q or something like that. So, but if you take that ratio, negative b divided by negative a, you still get b over a because it cancels out the negatives. So, what is that angle? Well, that angle is tangent of theta plus pi. So look at that last equation. That's pretty straightforward right there. Tangent theta is b over a. And b over a is the same thing as negative b over negative a. And then negative b over negative a is the coordinate in the third quadrant. So that's going to be tangent of theta plus pi. So what does that tell me? That tells me although the sine and cosines period is 2 pi, the tangents are only 1 pi. And that's what that first row, third one over. Tangent of theta plus pi is the same thing as the tangent of theta. So its fundamental period is not 2 pi. Its fundamental period is only 1 pi. Doesn't work that way with the sine and cosine, but it does work for the tangent. So to get to that same location on a sine curve or a cosine curve, you have to go one complete revolution. But on tangent, you only have to go half of a revolution to get to the same ratio. So, well, I should say the same ratio simplified. All righty. Now, let's look at the next example here. So, using periodic properties to find exact values. So, the cosine of 480 degrees, well, 480 degrees is the same thing as 120 degrees plus 360. Now, 360 degrees is the same thing as 2 pi radians, and they chose to use degrees here, though. So that's the same thing as the cosine of 120 degrees because 360 degrees is its fundamental period. And now we just got to know what the cosine of 120 degrees is. It's negative 1/2. So in other words, the cosine of 480 degrees is negative 1/2 as well. Now tangent of 11 pi over 4. Now 11 pi over 4 is the same thing as 3 pi over 4 plus 8 pi over 4. Now remember 8 pi over 4 is 2 pi. So that would be the same thing as what? Tangent of 3 pi over 4. Now you're like, well, wait a minute, 2 pi was not its fundamental period. I know, it wasn't. Pi was its fundamental period, but if you have 1 pi and then add another pi, you're back to the same location anyway. So its fundamental is, 2 pi is not its fundamental period, it's just basically 2 times. So it still works for this one as well. And the tangent of 3 pi over 4 is negative 1/2. And then the sine of 7 pi over 4, well, 7 pi over 4 is the same thing as, 7 pi over 3 is the same thing as pi over 3 plus 6 pi over 3. And 6 pi over 3, remember, is 2 pi. So that's the same as sine of pi over 3, which is root 3 over 2. So, all right. So that shows you that you can find trig functions evaluated at larger angles by making the smallest angle possible between 0 to 2 pi. So the angle comes really, really large, like 480 degrees, take off one revolution, knock it down to 120 degrees. That makes it more manageable and so therefore more doable. Okay, 11 pi over 4, take off a couple of periods, a couple of fundamental periods, and which is one revolution, to tell you the truth, and you go down to tangent of 3 pi over 4, and that's more doable. So if you have any questions on this discussion, you let me know, and you have a good day.